let's now consider the case when the complex potential is equal to z square. In this case, we know that the real part is just equal to this guy, and the imaginary part is this 2xy. This complex potential corresponds to streamlines or fluid flow around a corner. Just let us show you why this is so. You remember that the velocity is a vector with component u1 and u2, and we remember that these u1 and u2 are found by taking the gradient of this scalar potential, or the real part of this complex potential. So taking the derivative of this real part with respect to x, we obtain 2x, and taking the derivative with respect to y, we obtain minus 2y. So now we can see that this corresponds to the fluid flow in a corner with angle 90 degrees. And the reason is that when x is equal to 0 on this line, we see that u1 is equal to 0. So the component of the velocity is 0 in the x direction. And similarly, when y is equal to 0, we see from this expression that the y component of the velocity is equal to 0. So this means that we have a fluid flow around this corner. In order to find the streamlines, we have already mentioned that we should put the imaginary part of the corresponding complex potential equal to some constant. So when this guy is constant, we have it corresponds to lines where the fluid is flowing. So just write this 2xy equal to some constant. We can divide by 2x on both sides and obtain the expression of y in terms of x. So we see that this is a hyperbola for each value of k. We have illustrated it for the case when k is equal to 1 here. And so in this case, y is just 1 over 2x. It's possible to see that the velocity along such a streamline has a maximum value on this line when x is equal to y. And let us see the reason for this. We know that the absolute value of the velocity is just the square of this, and now replacing u1 with 2x and u2 with minus 2y, and then use this expression y is equal to k over 2x, then we obtain this expression. This expression we obtain. So let's now find the maximum value of this. We don't need the square root because the square root is just giving us trouble when we are trying to differentiate it. So we are only finding, it's enough for us to find the maximum value of the square of u. So how can we do this? Well, it's easy. We take the derivative of this. It's 2x minus k square over 2x in the power of 3. And when we are expanding this as a fraction, we obtain with the same we obtain two fractions with the same denominator, and we therefore can subtract in the usual way. So we obtain this expression, and when is this equal to 0? Because 0 is a value we obtain when this guy has a maximum value. Yes, then this must be equal to 0 also, so we obtain that x to the power of 4 must be equal to the square of capital K over 4. And therefore x must be equal to the square root of capital K over 2. So, well, now we have found this value of x, and the corresponding value of y is equal to, yes, k over 2x. That's the expression for the streamline, and we just replace x by this found value, this candidate for the extreme value. And we obtain, after some calculation, that this is equal to the same value, namely the square of capital K over 2. And this proves that x and y is equal when we have a maximum value.